This lesson is all about chemical equilibrium, and equilibrium is actually a topic that is really important in the world of chemistry. So in my AP class, we spend weeks and weeks doing some equilibrium problems, but in this class, we're just going to introduce it and kind of go over what it means and how to calculate the constant. So first of all, if you see a forward arrow, what that means is that the reaction is not reversible. So there are certain reactions, like exploding something, that you can't make it go backwards. Or baking brownies. If you really like brownie batter, you can't unbake the brownies and get them back into batter. But most reactions are actually reversible, which means if you take water and break it apart into hydrogen gas and oxygen gas, you can then take those gases and stick them back together into water. So most of them can go back and forth. And it's shown with a double arrow. And in real life, we actually write it on top of each other, so the arrows would be written like this. And the main idea to remember here is this word, the word rate. So most people see the word equal and they think it has to do with equal amounts, like maybe you have equal amounts of reactants and products. And really what it means is how fast the reaction, the forward and reverse reactions are going compared to each other. So when the forward reaction is happening just as fast as the reverse reaction, we call it chemical equilibrium. So in the example that I just said, that water example, we can break water apart into hydrogen gas and oxygen gas. We do have to balance it like this. And then also that hydrogen gas and oxygen gas can stick back together to make water. So if the water is breaking apart at the same time that the other two gases are sticking back together, we call it chemical equilibrium. So keep in mind that it has nothing to do with how much stuff you have. It has to do with the rates of the chemicals. And several things happen at this point. The first thing that happens is that you have constant data. So constant means it's not changing. So it doesn't mean that you have 50% water and 50% gases. It just means that once it's reached equilibrium, because they're exchanging particles at the same rate, the numbers will stop changing. And when we say numbers stop changing, we call that constant. And we can use the constant to calculate whether or not we have more reactants or more products once it's reached equilibrium. And we say it lies on the product side or lies farther on the reactant side, just means you have more of one or the other. So first of all, this is the equation that we're going to use. There are three things that you need to keep in mind. So first of all, notice that the products are over the reactants. And that's really hard because studies show, so here's reactants and here's products. Reactants are on the left, products are on the right. Studies show that people read fractions top to bottom, and we also read left to right. So it's really hard to flip it and put the products on the top. So the way I tell my students to remember it is if you put P over R, you see how R has two legs, so the fraction doesn't tip over. If you put the P on the bottom, P only has one leg, so the fraction is going to tip over, so that does not happen. So that's just a little silly way to remember which one goes on top and which one goes on the bottom. The brackets means concentration, and we haven't talked about concentration yet. That's in our next chapter. It just means how many particles you have in the solution. So for a sample of Kool-Aid, if you dump a whole lot of the red powder into your drink, it's a very high concentration. If you do mostly water with just a little sprinkle of Kool-Aid, we say it's a low concentration. So the first thing to remember is products go over reactants. The second thing you need to know is that coefficients are going to become exponents. So for example, if R had a 2 coefficient in the reaction, then when you put it into the fraction, you're going to square it. If P had a 3 in front of it, then you're going to put it to the third power. And then the last thing to keep in mind is that you do not use solids or liquids. So if you had a reaction where you had X turning into Y, but Y was a solid, when you plug it into your fraction, products go on top, but you don't have anything that you can put on top, so you would just put a 1. So we're assuming that X is maybe a gas. So that expression would look like this with a 1 on top. So don't include solids or liquids, but you can use things that are aqueous or things that are gases. And I have one more thing to show you before I calculate this with you. If K ends up being greater than 1, then equilibrium lies on the product side, and you can kind of figure that out. Remember that we have products over reactants. So if you know how fractions work, if the top of the fraction is big, you're going to get a number bigger than 1, so that means you have more products. If the bottom of the fraction is big, so like let's say if we're comparing 10 over 1 to 1 over 10, if you're doing 1 over 10, it's going to be a very small fraction, so that's going to be less than 1. And so if K is less than 1, it means you have more of the reactants. All right, so here's our first example, and I didn't put the states of matter here, but I should have, so let's go ahead and add those. These are all gases. So the question says, what is the equilibrium expression? That's a fancy way to say, to set up that K fraction. So you're not actually going to calculate anything yet. The first thing you're going to do is just set up the fraction. So let's say K equals, and you're going to set up your fraction line. You're going to put products on the top. So in this case, we only have one product, and it's NH3. Actually, the first thing you would do is look at your reaction and scan it for any solids or liquids, and go ahead and cross them off so that you're not tempted to put them into your K fraction. So again, you only use things that are gases or AQ. So NH3 is our only product, so we're going to put that on top. Then the other rule is that if it has a coefficient, which is the big number in front, you're going to raise that to the power of that coefficient. So that's going to be squared. And then we're going to put the reactants on the bottom, and we have two of them. We have N2 and we have H2. And N2 doesn't have any coefficients, but H2 has a 3 coefficient, so that needs to be cubed. Now be careful, when you have two things next to each other, make sure you don't stick a plus sign in there. They're being multiplied under that fraction, they're not being added together. So for some reason, some students stick a little plus sign in there, and you shouldn't. And that is the equilibrium expression. So if that was the question, you're done, just set up the fraction. Sometimes they want you to actually calculate it. So now what we can do is use these numbers from the question. I'm going to circle them in red so you can see them better. And we're going to plug in those numbers. So NH3 has a concentration of 1.8 molarity. We haven't learned what molarity is yet, but we will soon. So we're going to plug that in for NH3. Don't forget to keep that square on the top. N2 has a concentration of 1.5. And H2 has a concentration of 2. And don't forget to keep that 3 as an exponent. And then you just type it all into your calculator. And if you do this one correctly, you should get that K equals 0.27. And so now what we know is that because K is less than 1, we can say the equilibrium lies on the reactant side. Equilibrium lies on the reactant side. And that just means that you have more reactants than products once you reach equilibrium. And that's it for this lesson. So what you're going to do for this progress check is to first, numbers 1 through 5 on your progress check, you're just going to set up the fraction. Be careful because there's some solids and liquids in it. And then the last 3, you're going to actually plug it in the numbers. So you'll actually get a final number as your answer. And just remind me during class, and I will go over the answers for all the fractions to make sure you got those right.